Okay, lesson 2.2, length of a line segment. So we have already learned how to find the midpoint of a line segment. We've worked quite a bit with slope. Essentially today we're just being introduced to another formula that will allow us to find the length between 2 points on a Cartesian grid. So we have a little investigation here. We have Jan and Tara are planning a canoe trip on Georgian Bay. The dock where they will launch the canoe is at point A at 2-2 on their map. The campsite where they will stay the first night is at B at 6-5. And the campsite for the second night is at C 7-1. Plot points A and B on grid paper. So all we're going to do is use our little grid here, and we're going to work toward graphing this situation. Okay, so we're going to plot point A at 2-2. A 2-2. We're going to plot point B at 6-5. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5. It's right here. B at 6-5. Always give the name of the point, that's the capital letter, and also the location of the point, that's the coordinates x, y. And our instructions ask us to draw a straight line in between them. So grab a straight edge, connect those two dots, and we're going to then draw a right triangle below AB in order to show its rise and its run. So along the horizontal axis, we're moving from 2 to 6. And on the vertical axis, we're moving from 2 to 5. And we show that it's a right triangle. Generally, in order to not clutter up your graphs too much, if you're drawing these lines, you'll use dotted lines. And now, how does that help us to determine the length of AB? How is that helpful? Good, so the connection that we've made is that in a right triangle, a squared plus b squared equals c squared, where c is always the hypotenuse. So what we have here then, if we call this side A and this side B, the two legs of the right triangle, we have the length of the run squared plus the length of the rise squared equals the length of AB squared. Okay, so all we have is the point A and the point B. But because we're on this grid and we can see that the run is 4 units and the rise is 3 units, then we can actually just use our Pythagorean theorem, a squared plus b squared equals c squared, in order to get the length of this line. And we can rearrange this equation also in order to express it in terms of AB. What does that mean? It means we can get this equation in such a format that AB is on the left and all of the other stuff is on the right. And when we know the two coordinates, we will know the run and we will know the rise, and we can just plug that information in and solve for our unknown length. So a couple of notes on the bottom of page 10 to find the distance, between 2 points, to find the distance between 2 points on a grid. Apply the Pythagorean theorem. A squared plus b squared equals c squared. I'm just going to draw over here a situation that we might use this in. All right, so we would have A, B, C, where C is always the hypotenuse. But what we actually want to have is this in terms of AB. So we're going to call A x1, y1. That's where it is. That's going to allow us to apply this to any location on the graph. We're going to call B x2, y2. Okay? So now when we're talking about A is only the horizontal distance between A and B. Okay? The horizontal distance is represented by the x values. So what we're really looking for A squared is x2 minus x1. The difference between this location on the horizontal axis and this location, the difference between those places is the distance of this line. Okay? So A we can replace with x2 minus x1 squared. Okay? Same thing goes for B, the vertical distance. The vertical distance is simply the change in the y value from here at A to here at B. So all we need there for the vertical distance is the difference between our two vertical coordinates, y2 minus y1, that's squared. And what is it equal to? Well, in this case, the length that we're looking for is C, or AB, named after its endpoints, AB. And that is squared. I'm going to flip this around so that it's in terms of AB. So this sentence the same way has AB squared on the left. It has x squared minus, x2 minus x1 squared plus y2 minus y1 squared on the right. And now we're not actually interested in AB squared, we just want the length AB. So according to my rules of algebra, I can square root both sides of the equation. So on the left side, we end up with just AB, and on the right side, we end up with the square root of everything that's on the right-hand side. And at this point, you're going to put a big box around it and write distance formula maybe some stars, a balloon here or there. Okay, add this to your toolbox of formulas. We've seen how it's derived. It really just represents the x part, represents the change in horizontal. The y part represents the vertical change between the 2 points. And the square root and squareds is simply the application of Pythagorean Theorem. That's how the sides in a right angle triangle relate to each other. So today is all about just applying that formula in finding distances between 2 points on a grid. Okay, as we move into our examples, I just right away write the formula that I know I'm going to be using. I write it at the top. Your goal is to have this formula memorized so that you can apply it on tests and quizzes really easily and use it whenever you come across 2 points that you need to know the distance between. In example 1, we have a machine part. So to make round parts, programmable machine tools often use a coordinate system with the origin at the center of the part. How far apart are the centers of the mounting holes A and B in this cam? The coordinates are measured in centimeters. We're going to round our answer to the nearest tenth. So we've already seen how we derive the formula. Now all we need to know is that we're going from A to B. So I'm just going to leave my formula up there, and I'm looking at the length AB, and all I need to do is insert what I know. Well, let's say that in this case, x2 and y2 are going to come from point B, and x1 and y1 are going to come from point A. Okay? You don't need to mark this out for yourself, but you do need to remember to be consistent. If A is x1, y1, then please make sure that you have each bracket in the same order. x2 minus x1, y2 minus y1. X from B minus the x from A, plus the y from B minus the y from A. They have to be in the same order. You can't swap them. It won't work. Okay? So here we go. Let's fill in what we know. In this example, I can see that A is at the point -3, +5. And B is at the point 2, -4. So here we go, just plugging in what we know. x2 is the x-coordinate of B, that is 2, minus the x-coordinate from A, which is -3. Look at how you have to write that, okay? Don't forget, it's 2 minus -3. We're going to square that bracket, and now add the change in, the square of the change in y, which is y2, -4, minus the y from A, which is 5, and that's going to be squared. We're going to leave the square root symbol. We're going to work with everything underneath that first. We're going to simplify our brackets. So here in the first set of brackets, we have 2 minus -3. That's 2 plus 3. That's 5, and that's going to still be squared. And then inside the next bracket, we have -4 minus 5. That's -9 squared. 5, we still are under the square root sign. We have 5 squared is 25. Plus -9 squared. It's a negative times a negative, so it's going to be positive. Any number squared is positive. Remember that. That will come back, that concept. And 9 squared is 81, so we're adding 81 here. So now we're looking at the square root of 25 plus 81, which is 106. And the final step you do in your calculator, you take the square root of 106, and you round it to 1 decimal place. You find out that it is 10.3. So what does that mean? Well, that means, therefore, the mounting holes, right, we're applying it back to our word problem, the mounting holes are 10.3 centimeters apart. Okay, all we did was we were given 2 points. We wrote our distance formula, our length formula. We applied it by putting the appropriate coordinates into the right spot in the formula. We used our basic algebra skills, arithmetic really, to solve it out and rounded our answer to 1 decimal place. Okay, in example 2, we have an air ambulance service. They use a grid system to help estimate flying times and fuel requirements. The coordinates on this grid are distances in kilometers, east and north of a reference point on the lower left corner of a map in northern Ontario. Okay, so our grid, I believe you have it printed there. Yeah, you can see. Good. So you have a grid and all the points are in the first quadrant of that Cartesian plane. A helicopter ambulance picks up a patient at point P. So find point P and put 96, 197 in. That's the coordinates of point P, 96, 197. The nearest hospital that can provide the treatment that the patient needs is in Timmins at point T. So we have that hospital up in your picture at T, which is at 200, 296. You can input that. And you have a hospital in Sudbury down here at 232.80. A says, to which hospital should the helicopter take the patient? And then we're going to list any assumptions that we made based on this real-world possibility. Okay, so really all we're asking is, which hospital is closer to the patient? So it's really just 2 questions in one. We're going to find the distance between PT and we're going to find the distance between PS, and we're going to find out which hospital is closer, which distance is less. So first, PT. PT equals big square root sign. My formula is still written at the top of my practice problem page, so I don't have to rewrite it every single problem unless I'm having a really hard time remembering it. Then maybe I should rewrite it every single problem. But all I have to do is pick one of the points to be the first point and one of the points to be the second point and plug in the coordinates. Now it doesn't matter which point I choose to be x1, x1, y1, and which point I choose to be y1, y2, x2, y2. It doesn't matter which one I do as long as I'm consistent, okay? So I can start with my x coordinates. I can start with point T, 200 minus 96 squared. Then I'm going to add the difference in my y coordinates, making sure again I start with point T. 296 minus 197. Okay? And then I can work that down. Under the big square root sign, 200 minus 96 is 104. And 296 minus 197 is 99. Again, because they're both positive numbers in this case, you don't even really need those brackets, but it might help you to keep the brackets around the numbers to see what you've done. This part you would put in your calculator, 104 squared plus 99 squared. Your calculator can do that in one step. You're still under the square root sign though. You have 20,617. And don't get tricked here. You are not done. That is not the length of PT is not 20,617. It's the square root of that. So in your calculator, you still have to hit that square root button, second function answer, and that will give you an estimated answer, a rounded answer of 144. And that is in kilometers. And for PS, we would do the exact same thing. I'm going to move over here to do PS. If you continue working down or to the side, whichever way you think you have enough space. But PS uses the exact same distance formula. I'm going to plug in what I know. Go ahead and plug in the values. See if you can do it correctly. Make sure you use one point, then the other point. Be consistent. And once you have it set up, you can check on the board. Now again, ours might be slightly different because it doesn't matter which point you start from. But you could have 232 minus 96 in the first set of brackets squared plus 80 minus 197 in the second set of brackets squared. If you work that out, 232 minus 96 is 136. That's going to be squared. And over here, you notice you're going to be into the negatives. 80 minus 197 gets you negative 117 squared. Now, the reason that it makes no difference which point you did first, one of them you're going to end up with positive 117, and one way you're going to end up with negative 117. It doesn't matter because once you square it, what happens? It becomes a positive anyway, and 117 squared is going to be the same as 117 squared. So under our radical, under our square root sign, we have 32,185. We're not done yet. We take the square root of that, which if I just show you quick in your calculator, I don't seem to have a good calculator here. So again, if you were doing this on the calculator that you have, then straight from this section underneath the radical, okay, you could type 136 squared, which is over here, this x squared button on the left. You could right away click plus, and then if you use your brackets, you can go bracket negative 117, close bracket, squared, and your calculator will come out with 32,185. Now you could have put in positive 117 squared and you would get the same answer. If you're going to do it as the negative, then make sure you use those brackets so your calculator knows what you're doing. Now the last step is really easy. I don't actually have to type in square root of 32,185. I just have to find my square root command, which is right here above my x squared command. It's a second function, so I have second function, square root, second function, answer. This button down here will simply insert the previous answer underneath the radical. You can see that there. You don't even have to close that bracket. You can just hit enter and boom, there's your final answer. The square root of 32,185 is 179.4017837. We will round that to the nearest kilometer. So we will say this is approximately 179 kilometers. So PS is approximately, this little dot above the equal sign means you've approximated, you've rounded this answer. We're looking at 179 kilometers. So which hospital should they fly to?
Timmins.
They should fly the patient to the Timmins Hospital. They should fly the patient to the Timmins Hospital. All we had to do was apply the formula twice, find out which distance was shorter. Now, quickly, B. It's a real-world situation. You're in a helicopter. You're taking this patient to the best hospital simply based on what's closest. But what other assumptions are you making?
Busy or not, maybe?
Yeah, maybe you want to know which hospital is busier, if your patient can even get help at one rather than the other. If Timmins is too busy, then you should just go to Sudbury. Maybe the hospital at Timmins doesn't deal with this kind of situation, or the hospital at Sudbury has specialists in this area of whatever you need for this patient. Good. It also assumes that you can travel in a straight line to both places. Okay, there's no large geographical impediments like a mountain or anything like that. Also, it assumes that you can land directly at each hospital with your helicopter, which nowadays almost every hospital has a landing pad. Okay, example 3 asks us to find the length of a median. So you can see how this example is getting us to apply the things that we learned yesterday or the day before about finding the midpoint of a side of a triangle and the median going from one point to the opposite side. So basically we're just going to be doing 2 steps here. In order to find the length, we first need 2 points. In order to find one of the points, it's going to be the midpoint of one of the sides. So just draw a quick sketch here off to the side. Don't do it too big because you're going to need some space. But we've got Q at 1, 5. Then we've got R down here. It is at 7, negative 1. Do you guys have this picture already? And then we have P at negative 2, negative 2. Okay, so I've drawn the triangle without drawing the Cartesian plane. This thing crosses the x and the y axis. You know that because it has coordinates that are in negative land as well as coordinates that are in positive land. I just haven't drawn that part. That's okay. We are looking for the median. We're going to deal with the median from P. There is only one median from P, and it extends from P to the midpoint of the opposite side. Okay, so that's what the median from P looks like. We're going to call this point M. It's often easiest to call the midpoint of something point M. It also tells you exactly which formula you're going to be using. You're going to be using the midpoint formula. So again, if we went through our steps, we could do our steps, we could label them, list them, and then do them in reverse. So what we need is the length of median. That's obvious. We're going to use the length formula. But in order to do that, we need 2 points. Well, what's our second point going to be? It's going to be, by the definition of a median, it's going to be the midpoint of QR. Okay? And we know Q and R, and we know our midpoint formula. So we're going to do this first. Then we're going to be able to apply our length of the median. Here we go. First, finding the coordinates for point M. Midpoint formula. I'll go steps. 1. Find midpoint of QR. Midpoint formula, capital M, X, Y in brackets is equal to, and we're looking for coordinates. We're taking the average of the X's of Q and R, and then for the Y coordinate, the average of the Y's. So we have 1 plus 7 over 2 for our X coordinate, and our Y coordinate is 5 plus -1 over 2. Simple arithmetic, 1 plus 7 is 8, 8 divided by 2 is 4. 5 plus -1 is 5 minus 1, that's 4, divided by 2 is 2. So there we go, our midpoint, you can add that to your diagram, is at 4, 2. Now, we can step into step 2, apply length formula for PM. PM equals, I'm going to rewrite the length formula because I don't have it written anywhere else on this board right now. It is x1, or sorry, we can do x2 minus x1 squared plus, in brackets, y2 minus y1 squared. Now we simply plug in what we know. Again, it doesn't matter which point I take to be point 1, could be P or M, as long as I'm consistent. So here we go, under the radical sign, always draw your radical sign first. And we're going to go in the first bracket, 4 minus -2 squared. Second bracket, we're going to go 2 minus -2 squared. Draw my radical. 4 minus -2 is 6. I'm going to do 2 steps in 1. 6 squared is 36. 2 minus -2 is 4. 4 squared is 16. So we're looking at the square root of 52. This is where you would chuck it in your calculator, and you would get an approximate length for PM.
7.5.
Yeah, it looks like it wants us to keep the exact length. So if it's asking for an exact length, you would just leave it as the square root of 52. This is exact. I don't need a dot above the equal sign. It really is this length. Okay, if you're applying this to a word problem, then you would usually estimate, in which case you would type this into your calculator. You get second function 52, second function square root 52, you get 7.2. Good. So this is the length of the median from P in triangle QPR. Okay? We don't have any units given, so that's another indication that square root of 52 is a good answer. As it's not a real world situation, there are no units given. Okay, it's applying the things that we've done before. This was first find the midpoint, then apply your distance formula in order to get the median. Your practice problems for 2.2 are listed on the bottom there. They're from your Math Power 10 textbook, page 71, and there's a whole string of them to do. Come with questions tomorrow.